Okay, Luke, so I've looked through your program and I'm not sure exactly what all is going on. So sorry to have been not as available. I had to go out of town unexpectedly. And I won't be back in town until tomorrow. But I did want to throw up a video here to send you a video where I go through what the quick sort and the merge sort should look like. And I think that you're still having trouble and that starting in JGrasp, I think it's just causing you more trouble than it's worth. I think that C++ is similar on different systems, but you can't really take code from one and put it on the other. It introduces all kinds of errors. For this last problem set, I think I would, well, I guess we've got two more. The next problem set, then I would focus on getting it to work entirely on the server and not worry about getting it working on the PC. Okay. So the quick sort and the merge sort are both going to sort, at least in the way that the problem assignment's written, are going to sort linked lists. So we're going to start from the linked list. Okay, so we already have in the book, and I think I put those in the temp directory, we have a linked list type that lays out all the basic behavior of linked lists. And we also have an ordered list and an unordered list that are in the book. Okay. So if it's already an ordered list, we know that as new items are added, they're automatically put in the right spot, and there's not a need to sort them. Okay, so what we're doing now, we're gonna work then with the unordered list, which just inserts it wherever it wants to insert it, and we're going to create the merge sort and the quick sort there. Okay, and again, I'm not sure where you're running into all your issues at, but hopefully going through this, then you may have a better idea. Okay. So I will say that this is homework that a student last semester had worked on and did a good job. So we'll go through his code. Okay. So we're setting up some global variables because the point is we want to figure out how long these sorts take. Okay. And then what I didn't see on yours, at least when I looked at it just now, was the fact that these are templated functions. Pretty much all the functions in the book, the same thing we're talking about trees, are templated, which means that you don't need separate code for a list of ints versus a list of doubles versus a list of strings or a list of circles that you make. Okay. So that's where this template class type comes in. And I don't know if we talked about this or not in class, but it's in the book. Type then becomes a variable for what the type is. Okay. So we put that there, and then we're going to create this class unordered linked list. Again, this should be in the book, most of it at least. And we're going to inherit publicly from the linked list type. We have to make sure we send along that type. So when you create your linked list, unordered linked list, it's going to create a linked list of that same type. Okay. And then here we have just, some basic stuff here. We've got the search function. Okay. And it's going to take in a search term here. Okay. And that search term, then we're going to look for it. And, we've seen this before. Okay. That we're setting up this current pointer that we're going to use to traverse through the list. Okay. And again, since first is defined in the linked list type as one of its member variables, we have to use the this to prepend that. The book doesn't do that, but we have to get it to work on our compiler. Okay. So by setting current, which is just a node type variable pointer equal to this first, it's pointing to the first node in the list. Okay. And then we just go through it and look for it. And then if it's done, we set found equal to true. Okay. Basically. So this is not super efficient in that as soon as it finds it, it doesn't. Oh, no, it does. Yeah, it does. Okay, there we go. I was going to say it doesn't kick out, but this does this and up here. Okay, so if it's found, then it kicks out and returns found. If not, it's going to return the false. Okay, so it returns found there. Found is originally set to false here, and it's only set to true if it's correct. Okay. So this is again from the book, how on inserting first. Again, the type is important here. Okay. And There's the insert first, there's an insert last, just goes to the end. So this one, so on the insert first, we have to always create a new node. And in this case, we're just going to reroute the list. This new node goes to what was the first node. We then change what the first pointer points to this new node. That's all we're doing here. Okay. Then insert last, we have to traverse down to the end of the list, add one at the end. Okay, and that for sure is in the book. There's delete node. Again, we have to figure out, we have some different cases here. Okay. If the list is empty, you know, which means that again, this first, that pointer is equal to null pointer, then we know the list is empty and we can't delete from an empty list. If not, we have our case 2, okay, where we're going to go to see if the list has only one node and you delete it, then you delete it and that's it. If not, we have to search the list. Okay. And then the third case we have is that we find the list, we found the item in the list, so then we delete the node. That's what we're doing there. Okay. And that's all the basic stuff for the unordered list. Okay. That calls upon the linked list code that we have. And then we have the sorts that we're going to need for our sorting shootout. Okay. Again, all of these are going to use templated functions. Okay. So we have, again, our temp one here, which is going to point to this first. This first refers to whichever list is on the left-hand side of the dot selection sort. So if I have list 1 I've created and I do list 1 dot selection sort, then list 1 is what this refers to. Okay. And then we just go through and do the selection sort like this. Okay. Insertion sort works a little bit similar way. Okay. Notice we're keeping track every time we do a comparison. That's where we're going up on those. So before every while loop hits, there's a comparison gets done. And then we also have this key assignments when we're making a new assignment that shows how busy the sorting algorithm is. Okay. And then for the quick sort, we have some different parts. Okay. So the quick sort itself comes on down here. So here's a quick sort function. Okay. And the things that it's going to call. Okay. So it starts with calling the partition, which we just looked up above. We'll look at again in a second. Again, we're looking at this compare for the quicksort compares. Okay. And then we're going to use this partition to either go left or right with it, basically. Okay. And then we're calling this quicksort recursively here. Okay. And then up here, again, we have the partition function, okay, where we're going to go through and we're sending along the first and last so we can do a sublist if we want, okay, and then we're going to create a pivot and we're going to do those partitions. Partitions, again, are semi-sorting the list, okay, that's how the quicksort works, okay. And again, all this works perfectly with the linked list code, okay? Then we have the merge sort. If you look at the merge sort down here, we start with the merge sort function here, which again is going to take a first and 2 different pointers, first 1 and first 2, okay? And then we've got this pointer to the last node of the merge list, the last small, the new head, which we're going to use when we're merging the list back together. Oh, it's the merge list, sorry, not the merge sort. Let's get to the merge sort because that's the last thing we do have to put together. So there's this one, remember, we call the merge sort, which basically does nothing much except call the recursive merge sort on the first element, okay? And we do this so we can call that merge sort on things other than the first element, but the first time we call it the first element, okay? So there's the recursive merge sort, okay? And then as long as the list is not empty, we're going to see if the list has more than one node. Then we go through the steps we do on merge sort. We're going to divide the list. We're going to call the recursive merge sort on the head, which is the first part of our division of the list. Then on the other head, okay? Then we're going to merge those lists back together, okay? So that's what the recursive merge sort does. So if you go back up to here, okay, it starts with the divide list. Okay. I think that's the first thing we have on this one. Yeah, it's the quick sort. So here we go. Yeah, so the divide list then is going to be the first thing we do on the merge sort. Okay. And this is going to go through and do that for us. Okay. We have, again, the different cases. The list is empty. The list has one node. And then we get down to here. If the list has more than 2 nodes, we're going to go through and merge those lists. Okay. Create 2 lists from the one. Okay. And then coming back the other way, we're going to have the merge list where we have the 2 different lists, the first one and first 2, as he's calling them, that are the 2 sub lists we're putting back together. Okay. And this is where it's going to go through using this last small and the new head. The new head points to the new merge list. And in the algorithm for merge sort, we're going to take the 2 lists that we're sorting, and those themselves are sorted by the time they get to that point. Remember, merge sort goes all the way. There's only one item, and one item has to be sorted. So at this point, we have 2 lists, and each list has the smallest element. We compare those 2 to see which of those 2 is the smallest. Okay, so list 1 smallest versus list 2 smallest. The smallest of those 2 becomes the smallest of the new one we're creating, and we delete it from the original one. And we keep going through until we've added all the points in order. Okay. So that's what this is doing. And the result of this, when it comes back, will be a new list that's a merge of those 2 lists. Okay. And then we have the cases here that one of the lists will run out first. Okay. If the first sublist is exhausted first, then everything from the second list just gets added on to the end. Okay. It's already in order and it's bigger than everything else in the list. The other option here is if the second sublist gets exhausted first, then you just do the opposite. Okay. And then we finally return this new head, which is the pointer to the first element of the new linked list that we've created by merging them together. Okay. So you would ask in your email for an example of why things are not working. And it seems that you don't have the infrastructure for the linked list working properly. Okay. So with that not working, that makes everything else just more difficult than it needs to be. Okay. So hopefully this video will help you to figure out what it is that you're doing wrong and be able to get those things working. Okay. Because the trees are going to be pretty similar. Okay. That we're going to need to deal with the templated types. We're going to need to, be able to take what's in the book and turn it into working code. Okay. If you have further questions, let me know. Again, I should be back in town tomorrow, and I should be available for a Zoom anytime after tomorrow would be my guess. Okay. So anyway, hopefully this is helpful to you.